Hello and welcome back to Refrigerator YouTube videos, and welcome to Putting in Bay, where Putting in Bay is the putamen, and it's all about the motion of the ocean in this Refrigerator YouTube video because we're talking about movement. And so, let's begin. Alright, so we're going to look at three key ideas in this, and we're not talking about any circuits here. We're just going to talk about three overarching ideas, and I believe if you have these set in stone, they'll really be able to help you understand the basal ganglia and be able to score high on the questions. And with my research I did in undergrad, this is kind of where I began with the basal ganglia, and I believe it just opened new windows and doors for me to really see the light of how beautiful the system can be. Alright, so let's begin. Point number one is the thalamus excites movement. And notice when I say excites movement, we're only talking about a movement here. We're not talking about neurotransmitters. We're not talking about excitation or inhibition at the neurotransmitter level. We are just talking in general about what excites movement. So if the thalamus could have his way, he would always excite movement. That's all the thalamus wants to do. And that's why it's here in green. Also, if you look here at the thalamus, I underlined the M to help remind us that it's all about movement. So if the thalamus could have his way, he'd always be having us move. All right, now let's hop down here to point number two. The globus pallidus internal, the internal globus pallidus, it always wants to inhibit movement. And look at this. This is beautiful because it's right here. There's your eye. There's your eye and inhibit. Boom, bada bang. We're going over here. We're inhibiting movement. And how do we do that? We go up here and we inhibit the thalamus. If you have those two keys down, it'll be able to understand the whole direct and indirect pathway. Okay, so stepping back, let's go down here to point number three. Putting in Bay. It's actually it's a body of water up in Cleveland somewhere, I believe. And I just thought about it, the movement of the ocean, Putting in Bay, it just sounded like putamen to me. And the putamen, where do you put in your boat? You put it in the bay. And the putamen is where all the input starts. If you want to start anywhere with the basal ganglia, start at the putamen. It's getting all the input, okay? Starting there. Okay, and that's why I labeled it 3, to remind us that there are actually 3 receptors on putamen cells. Now I know we talked about D1, D2, we'll get all of that when we go into the direct and indirect pathway, but I like to think of the putamen as having 3 receptors on them. And the first of those receptors, and it's in those putamen cells, in the striatum, the putamen, and in those cells, there's 3 receptors on each cell. There's a dopamine receptor, an acetylcholine receptor, and a glutamate receptor. Okay, let's start with dopamine. Well, look, it is labeled in green. So what does that mean? Dopamine is the fuel that we need for our boat and Putting in Bay. Without dopamine, there is no movement, there is no fuel. It is like, if you're driving a car, you'd be like, duh, we need fuel. D-A, duh, duh. Gotta have fuel to get your boat going. Dopamine always helps us get to movement, whether it's the direct or indirect pathway. Start there. Dopamine gets movement. All right, now we're going to move over to acetylcholine. And I should mention with dopamine, it's all coming from that substantia nigra pars compacta. That's our source. That's the gas station. The substantia nigra pars compacta is the gas station. Dopamine is the fuel. All right, now let's hop over here to acetylcholine. Well, it's in red because it has antagonistic effects compared to dopamine on motor. On motor, just keep motor in mind. It is inhibitory to movement in motor. And what I like to think of with this is like if you're driving a boat or driving a car, there's always that acetylcholine in front of you that's making you late. You get my drift? Okay, so it's always inhibiting your movement because there's always that acetylcholine in your way. All right, always inhibitory. Doesn't matter where. For this system specifically, it's inhibitory to movement. Okay, then we have glutamate over here in black. Okay, it's the 3rd receptor type found on the putamen cells. And I put it in black because it both excites and inhibits movement. If we're in the direct pathway, it excites movement. If we're in the indirect pathway, it inhibits movement. And that's where we'll pick up next in the next Refrigerator YouTube video.